Hi there, welcome to your lesson on angles of elevation and depression. Check out this diagram here, it shows you what those are. Okay, this lesson relies on your understanding of trigonometric ratios, which was the last lesson. So make sure you are familiar with sine, cosine, and tangent, knowing that sine of an angle is the opposite side of our hypotenuse, cosine of an angle is the ratio between the adjacent and hypotenuse, and the tangent of an angle is the ratio between the opposite side and the adjacent side. Knowing those, let's double check if we know how to work with those. Here's two questions. So even before we jump into our topic for this video, try these two to start. Two easy ones. How tall is the tree? Okay, in that case, using tangent, because we want the opposite and we know the adjacent, so we set it up here and solved. Okay, try this one here. In this case, you should have used the cosine ratio. Set it up like this when you solve that, and there's your answer. Very basic problems. If those are an issue, go back and practice trigonometry, basic trig a little bit before this video, which is going to have more complex stuff coming right up. Okay, so angles of elevation and depression. Imagine somebody looks straight ahead. When they look straight ahead, we say there's no angle. They're looking straight ahead, and they are looking across a horizontal, like they're looking horizontally across space. However, as soon as they raise their gaze, there's an angle of elevation. That angle is formed between the horizontal line and the new direction of their sight. If you look down from the horizontal, that's called an angle of depression. So up from the horizontal and down from the horizontal. Let's take a look. So again, defined angle of elevation is the angle you lift your eyes through to look at something above. So again, here's the horizontal. You look up. That is the angle of elevation. And here, angle of depression is the angle you lower your eyes through to look at something below. Here's the horizontal. Here's the angle you lower your eyes down from the horizontal, angle of depression. Okay, we're going to keep coming back to these a couple more times because students do a common error with angles of elevation and depression. Let's make sure we got it. So again, the key is from the horizontal, right? Here is the horizontal, angle of depression. Here from this tower here, here's the horizontal, angle of elevation. Okay, another diagram, same thing. Horizontal, angle of depression, horizontal, angle of elevation. Two people are looking at each other. But from this person's perspective, it's angle of depression, and from their perspective, angle of elevation. Okay, all of that we got to here. So what is the angle of elevation from hiker to mountaintop? Which of those four angles represents the angle of elevation from hiker to mountaintop? Well, that's angle 2. We can see here, angle of elevation. Okay, next one. What is the angle of depression from mountaintop to hiker? Well, that is angle 1. Now, finish this sentence. Angle 4 is the blank. Well, it is the angle of elevation from the cabin to the hiker. Finally, angle 3 is the angle of depression from the hiker to the cabin. Great. Now you are a master of that vocabulary. So let's check this one out. What is the angle of elevation from B to D? Pretty simple. It's at 15 degrees. Great. What is the angle of depression from D to B? And I hope you didn't put 75. This is the horizontal. The angle of depression is the angle that will be formed when you look from the horizontal. So it's that angle, which is 15. Of course, that diagram didn't include the horizontal, but that's where we've come to. This is the most common error made by people working with this vocabulary is they look at that and say angle of depression. No, the angle of depression is here and it is 15 degrees. Okay, let's try this problem. So now the problems, these are still trig problems, but they're tougher and they use the vocabulary of angles of elevation and depression. So from his studio window at point A, which is 6.5 meters above the ground, so imagine you have a building and somebody's 6.5 meters up that building. Okay, they're looking from that window, and the person is named Tomczyk. He views the top and the base of a building on the opposite side of the street. So imagine he's up in this, whatever floor in his building, 6.5 meters up. He's looking across the street. There's another building. He can look up to the top of the building and down to the bottom of the building. The angle of elevation and depression of the top and the base of the building are 55. So imagine him looking up, making an angle of elevation of 55, and then looking down, making an angle of elevation of 18 degrees. Can you draw that diagram? And once you have that diagram, your job is to find the height of the building he is viewing. Give your answer correct to 2 decimal places. I'm going to leave this open. Let's see how you do without any diagrams or anything. Let's go. Okay, let's check. Here's my diagram. Here's one building. Here's another. Here's Tom Chick's window. He's looking up, and he's looking down at the top and the base of the building across the street. He is 6.5 meters above the ground, so this distance is 6.5. I need to draw the horizontal. Anytime we talk about elevation and depression, we need the horizontal. Here's the horizontal line. We were told, okay, so this is also 6.5. Okay, and now the angle of elevation was 55 when he's looking at the top of the other building. There it is. Angle of depression is 18 when he's looking at the bottom of the other building. That's a good diagram for this problem. And the question is, how tall is this building here? Well, we know this portion of it is 6.5 meters because it's the same as we have here. However, how much more is this? So solve it now. In case you got it wrong the first time, now that you have a good diagram, try to solve it. Okay, we will use tangent, because tangent of 18 will give us this horizontal length. Tangent is opposite over adjacent. So it will allow us to solve for AB, which in this case is going to be here to here. When you solve that, you get 20 meters exactly across here. So that's 20. We needed that because in the upper triangle, we could not solve anything because all we knew was one angle. If you only know one thing about a right triangle, you're stuck. But if you know 2 things about a right triangle, you can move on with trigonometry. So now we know this length here, 20, and now we can work with this triangle. Okay, so which trig ratio would you use here? That is a tangent again. We're going to do opposite over adjacent. So now we're looking for this opposite side. We know this 20 now is our adjacent. Solving that, we get 28.56. But that's not the height of the whole building. That's only this portion of this triangle. We need to add the 6.5 to get the full height right here. Okay, not a bad problem, but it allows students to struggle with taking the words, making a proper diagram. I hope that makes sense because you're going to try another one right now. So, problem 2. Read this one to yourself and see if you can sketch a diagram. It's very similar to the last one. Let's see if you can sketch the diagram and then solve the height of the apartment block. Let's try. Okay, here's the diagram I have. It's the same idea. Wally's looking out of his office window, looks up, looks down. The distance between the buildings is 300. So in this case, this time you're given the distance between them, the horizontal length. Angle of elevation, 23. Angle of depression, 30, both from the horizontal. And how tall is this? So I labeled this H sub O and H sub E. You need both of those heights combined to get the height of the building. Okay, tangent set up in this triangle to find HE. And tangent set up in the bottom triangle to find HO. I guess that's HD. I put O here, but they're using D. That's okay. And then you add them up to get the total height. This one was actually easier than last problem because we had everything we needed in both triangles to find the missing part. Okay, hope that worked out for you. Let's look at one more. Here's problem 3. Read that, see if you can draw a diagram and solve it. Okay, there's my diagram. This one is definitely tougher, okay? A lot of students really struggle with this one the first time they see it. Let's see if we can make some things out here. Okay, what was told to us? Somebody's on the ground. There's an angle of depression of 30 degrees. Another friend is in a higher floor, 20 meters higher. They look down and have a different angle of depression. So let's see that here. So here's where you're looking at a friend. The friend is here. You're looking down at them from the window. And you have to draw a horizontal and show this angle of depression of 30 degrees. And then somebody 20 meters higher than you in the building right here also looks down at the same friend right here. And now their angle of depression is steeper because as they get higher, of course, it's going to be a steeper. You have to look down at a steeper angle, 55. With this diagram, it's a little complicated. What's going on here? Our goal here is this X, the distance the friend on the ground is from the building. So let me give you some things to start. Number 1, this angle is 30. This horizontal is parallel to the ground. So this transversal ensures that this angle and this angle are actually congruent. So this is 30. So now looking at this triangle, we can look at it as a piece of a larger right triangle. There's a large right triangle here. If I call this Y, this distance here, and then I actually combine these angles sorry, I know that's 55 again because this is 55 here and here, parallel lines again. Now, I have a fully labeled diagram now. Does this allow you to solve for something here? Let's try. Tangent of 30. So I'm looking now just at this bottom triangle, and I say tangent of this angle is opposite over adjacent, so y over x. Okay, the issue with this problem is that I've created an equation, but there's two unknowns, two variables, so it can't be solved. So what that tells you when you get that kind of situation is try to create another equation with the same variables. So is there another equation I can create? Let's take a look. How about tangent of 55? So now I'm talking about this whole red angle here, and now I'm talking about this full right triangle right here. If that's 55. Tangent is opposite, which is now y plus 20 is the full length there, over x. Notice we have x here and here. So now I have two equations that I can somehow combine. And now there's many ways to approach this, solving a system of equations, but I'm going to approach it in a certain way. I'm going to solve for y here, and I'm also going to solve the other one for y. Because if I rearrange both equations for y, I can then say that both equations are equal to each other because they will both equal y. So x tan 30 equals x tan 55 minus 20. And you can see how this problem is much tougher than the other ones. So maybe you had trouble getting it, but as we're doing it here, just make sure you follow the process carefully. Let's see how we solve that. Well, I move this x tan 55 onto the same side as this one here. And now I have both x things on one side of the equation. That means I can factor out x from this side here. I factor out x, and now I have my tangent 30 minus tangent 55. That allows me to solve for x because now I can divide both sides by this statement here. So that negative 20 was now divided by this. Punch that in your calculator, and let's see what result you get. That answer should be, whoop. Oh, I didn't even show it there. Okay, interesting. So let's check the answer together. One second. Okay, I just calculated it, and that answer is 23.5. So again, don't be discouraged if you couldn't get that problem. That's a very challenging problem. However, once the process was explained, if you could follow that step by step, great job. Even seeing the process might still be difficult, so just keep working at it. Okay, I have a final challenge problem for you. So if that was not challenge enough, I have another one for you here. Read this one here. See if you can set up a diagram. It might be in a way similar to the one we just had, and see if you can solve that. You're trying to find the height of that building. This one is going to be like the last one in that it requires a system of equations. You're going to create two trigonometric equations and combine them as we did in the last one somehow. So do your best. See if you can sketch the diagram and make this work. And here is a worked solution for that. Look at the diagram, look at my two equations, and notice with both of them I solve for h, and then since they both equal h, I set them equal to each other and continued there using some algebra, very similar to what we did in the last problem. That's a challenge. If you were up for that challenge, congratulations. Keep doing your best, and we will see you soon.